3.2 is parabolas, and you can see that if you slice a cone just so, that section of the cone is going to form a parabola. That's where it comes from. That's why this is called a conic section. So they give you two different equations for a parabola, but I think it might be more useful if we subtract this over. I'm going to subtract this over, so I'm probably going to look at it more like y minus h equals a times x minus k squared, or subtract this over here, x minus h equals a times y minus k squared. Both of those say the same thing, but I think the other way, the red way, I think is a little bit more useful. Now, they've got a couple of little sketches here, and there's a lot going on. But first thing you want to notice is that your parabola might be oriented up and down, or today we're going to see some that are oriented left and right. And that's going to, it's not going to be that much harder or that much different than the ones we've seen before. Now, if you look at a parabola, you've got something called a focus and something called a directrix. And that's actually how you could form a parabola, or that's the definition. And let's see if I can get this right. If I wanted to form a parabola, I would have a point right here called the focus, and I'd have a line right here called the directrix. And what a parabola is the set of all points that's equidistant from both of those things. So obviously right in the middle, there would be a point, okay? The distance from this point to point F and the distance from the directrix to that point are the same, right? This distance and this distance are the same. But take some other point, like let's say right here, right? This point, the distance here and the distance here are supposed to be the same. And right here. So the distance here and the distance here are the same. And so you just keep making points, point. There's all these points such that the distance to the point and the distance to the directrix are the same. Now, my drawing skills aren't the greatest, but you keep making these points, and what you end up with after you make all these points is this nice parabola. No matter where you're at, the distance from some point to the focus and some point to the directrix is going to be the same. That's how it's formed. And we don't really care about that. We don't really need to know about that, but that's what it is, and that's what a focus and directrix do. Now, as far as what are parabolas useful for, you might use one every night, because when you drive, your headlights kind of work using a parabolic shape. And the light bulb is actually like inside this parabola. And if you think about how a light bulb works, it's going to put out a bunch of rays. It's going to put out light rays in all directions, right? But what ends up happening is it reflects off this parabola off into a direction, and no matter what direction this light beam travels, it hits the parabola and reflects straight ahead and focuses all your light straight ahead so you can see. That's kind of how your headlights work. Or if you watch satellite television, it kind of works in the reverse. You've got a satellite up in space, and your satellite's beaming all these rays, all this information down, and it hits your satellite dish, and it hits somewhere on the parabola and reflects, boom, right into this thing. And so if you ever look up on somebody's roof and they've got a dish, there's also this device kind of in the middle of the dish, and you probably didn't really understand what that was, maybe, but what's happening is all these beams are hitting the parabola and then reflecting and focusing all of the data or all of the energy, all of the power gets focused into this point right here, and then it travels into your TV or whatever. So it does have some practical uses, believe it or not, and that's what we're looking at when we're talking about a focus. And it's probably the hardest thing is going to be for you to understand how do we get that focus and how do we get that directrix. What it's going to involve is finding this distance right here. And this distance is going to be P. So P is the distance between the vertex and the focus, but it's also going to be the same as the distance between the vertex and the directrix. It sounds a lot more complicated than it actually is. One thing you're going to need is you're going to need this equation. A equals 1 over 4P. And I don't really care if you memorize that, but it'd probably help. It comes up often enough that you probably want to have it memorized or whatever. So what's A? A is going to be this number right here, the number that's in front of the squared term. That's going to be your A, your coefficient. Just like in the quadratic formula, that first coefficient with the ax squared, right? It's the number that's in front of the x squared term, or I guess the y squared term, right? And what's P in that formula? Well, P is that distance that we just talked about, the distance to the focus, the distance to the directrix. So that equation is going to be important when we start talking about the focus and the directrix. Example 0, I made a typo. That should not say vertex, that should say focus. Find the coordinates of the vertex. It would have been easy. We can see the vertex right here has the coordinates 4, 1. That's not what I was trying to ask. I want to know the coordinates of the focus and the equation of the directrix. And people really struggle with that. Students really struggle with that because they don't know that formula. A equals 1 over 4P. You need to use this formula in order to find that distance so you can find what you need. A is 1/3, so I'm just going to plug it in right here. 1/3 equals 1 over 4P, and then I can cross multiply to solve this equation. 4P equals 3, divide by 4, P is going to equal 3/4. One thing that makes this lesson tough is sometimes the numbers are kind of gross, but P is 3/4. That is the distance. The distance between the vertex and the focus, or the distance between the vertex and the directrix. So use some common sense here. Go over to the picture and find the vertex. And that focus has to be 3/4 of a unit away. That's the distance. That's what P is. It's 3/4 away. So draw it 3/4 of the way to the next tick mark right there, and then you should be able to tell me the coordinates of that point. That's the focus point. And the coordinates, well, it looks like I went up. So just take that 1 and add 3/4. The focus is going to be 4, 1 and 3/4. 4, 1 and 3/4. Now, sometimes it gets different, like Math Excel or something wouldn't want to mix numbers, so they would say 7/4. And sometimes people get confused because we don't understand improper fractions as well. But 1 and 3/4, 7/4, 1.75, however you want to think about that y coordinate, it's got to be 3/4 above 1. Now the directrix, it's got to be that same distance. So you need to go down 3/4 below the vertex, but it is not a point. It is an equation of a line. And so you're going to have a line that looks like this. And that was, what would that be, 1/4? That's going to be 1/4 right there. So your directrix is going to be the equation y equals 1/4. It's not just a number. It's definitely not a point. It's a line. And so a line is going to have an equation like that. Found the focus, found the directrix. Number 1, graph this thing, give the domain and the range. Now, one thing that you can help yourself out with is just recognize that this is going to be a parabola. When you see a x and a y squared, when one of the variables is squared, it's going to be a parabola. But do what you did in circles. When you looked at circles, you probably said something like, okay, what x number is going to make 0? 4, right? And what y number is going to make 0? -2. That point is going to be not the center. We don't talk about a center of a parabola. We talk about the vertex. So the first thing I'm going to do is try to find the vertex. I've got the vertex at 4, -2. So 1, 2, 3, 4, -2. Vertex. Now, be really careful here. If you completely ignored those numbers, look at the equation. Look at the equation that was given to you and kind of just ignore those numbers. The equation would say x equals -y squared. If I just kind of squint away the vertex, do you see that the basic pattern of this equation, x equals -y squared? That tells you what the shape is and what direction it points. What we've seen before in the past, think about what we've seen. Usually we'll draw x squared and we know what that shape is. It looks like this, right? But then sometimes we have a -x squared, and so that flips it upside down. We've seen a lot of those throughout algebra. But now we're going to have y squared, and y squared, a positive y squared, points in the positive direction or opens up in the positive x direction. A -y squared, like we have now, is going to open backwards. And so memorize those 4 things if you need to, but I know what direction this is going to point. I know this is going to point like this. And the vertex just so happens to be at 4, -2. Now, if you want to get more points, you could make an XY table, but I don't want to do that. I'm too lazy to do that. You could. There's nothing wrong with that. It's a lot more work than what I'm going to do, though. I would much rather use my 1-3-5 pattern. We know squares. We know squares have a 1-3-5 pattern, right? 1-3-5. So let's use that. The only difference is instead of going up or down, we're going in that direction. We're going to the left. So 1-3-5. When I look at my graph, I'm going to start at my vertex. And I'm going to go left 1 and up or down 1. The second number is always 1. The denominator is always 1. I'm going to go over 3, up 1, down 1. Over 1, 2, 3, 4, 5, up 1, over 5, down 1. Look like that. Be very careful. Draw your parabola. That's pretty much what it looks like. Now think about domain and range. Domain. Squash it onto the x. Look at only the x numbers. Domain goes from -infinity to +4. Bracket. What about the range? Squash it on the y. Yeah, it's going to cover everything. All real numbers. -infinity to +infinity. Always start with the smaller number. I've seen some of you guys switching it around backwards, but we always go from least to greatest. Next. This one's harder automatically because I can't see the vertex. The last one I could immediately see the vertex. I knew where to go. I used my 1-3-5 pattern. This one I can't. Just like when we did circles, when we couldn't see the center, we probably had to do completing the square, and that's what's going to happen here. I'm going to have to do completing the square. So let's think about what we do. First thing I would do is probably get rid of this 6. Subtract the 6 over. I want to create space so I can complete the square. Yeah, you're going to work on the y term because that's the square, but I'm going to see x minus 6 equals 1/2 y squared minus 4y, and I leave that blank space right there. Now this one's tough, don't work ahead. That 1/2 makes this a lot harder than it could be. Okay, so when we've got that number in the front, what you'll want to do is kind of factor it out. And so I'm going to take that 1/2 and pull it out of that expression. Be careful. It's kind of hard to see what goes after the minus. You might try to put a 2 there, but that's not right. Think about distributive property. If I distribute it back, 1/2 times y squared, 1/2 y squared, 1/2 times minus 8 is where I would have gotten my minus 4. That's really tricky, I know it. And so when you pull that 1/2 out, you're dividing by a half. Dividing by a half, you're multiplying by 2. That's why that's an 8. So you're going to do what you do, and you look at this 8, and you're like, half of that 8 is minus 4, and you're going to square it back and get a 16 right there. It's the same as what we've been doing. You can factor that into y minus 4 squared. There's a 1/2 in front of it. But when we completed the square, when we put that 16 in, we threw off our equation. And this one's weird because of that 1/2. We did not throw off our original equation by 16. We threw it off by half of 16. If you think about what goes in that blank above is 8. We didn't throw off our equation by 16. We actually threw off our equation by 8. And so that's fine. If I'm going to add 8 out of nowhere, let's just add 8 to the other side as well. I'm going to add 8 to both sides. If I add 8 to both sides, now I'm balanced. And so the left side, x minus 6 plus 8, that's x plus 2. Okay, fine. I've got x plus 2 equals 1/2 y minus 4 quantity squared. That's the equation of my parabola. So when I look at this, I can immediately see the vertex. What's the vertex? Negative 2, 4. Vertex at negative 2, 4. Negative 2, 4 is right there. But I can also tell what direction it's facing. If you ignore the vertex part, then this looks like x equals 1/2 y squared. If you just kind of look at the non-shifted parts of it, x equals y squared, that's a positive y squared. That's going to open to the right. That's going to open in the positive x direction. So again, if you don't understand why the pattern works, the 1-3-5 pattern, then don't use it. All right. But I'm going to use the 1-3-5 pattern because I know how it works and I know it's really quick. The thing is, though, the thing you have to remember is even though I say it's a 1-3-5 pattern, technically it's not going to be a 1-3-5 pattern this time because that 1/2 is a multiplier. You're taking your squares and multiplying them all by 1/2. So you're taking your 1-3-5 pattern and multiplying by 1/2. 1 times 1/2 is 0.5, and 3 times 1/2 is 1.5, and 5 times 1/2 is 2.5. Feel free to use fractions if you'd rather. I think most people are better at decimals, though. 0.5, 1.5, 2.5. So since I already know what direction it opens, I'm just going to use that pattern and draw it out. So starting at the vertex, I'm going to go over 0.5 and up 1 or down 1. It's always 1. The second number is always 1. Then I'm going to go over 1.5, and that puts me right on the axis, up 1 to 6 or down 1 to 2. And then I go over 2.5. From that point, over 2.5 and up 1, over 2.5 and down 1. We can do more if we need to. I don't think we really need to, though. Might be nice to see where the the x-intercept is, I guess. But that's pretty good. That's pretty good for my graph. We want to know the domain and the range, though. Domain. Look at your x numbers. Looks like it goes from -2 to positive infinity. Your range, all real numbers. All right, number 3, give the focus, directrix, vertex, and axis of the parabola, x squared equals -4y. Then use the information to graph the parabola. One thing that's weird about this one is it's written in a weird order. We normally like to have the x squared on the right side, and it's not that it's wrong or anything. It's just a little bit trickier, I think, in my opinion, when it's written backwards. So I'm going to just flip-flop it. But I don't like that -4 in front of the y. I want my number in front of my x squared. That's where my a number is. And so I would probably isolate y here. Y equals -1/4 x squared. When I see that, I immediately know where the vertex is. Okay, you can write it like this: y minus 0 equals -1/4 x minus 0 squared, and that might make it more obvious that the vertex is at the point 0, 0. Maybe you could see that before we even started. The vertex was going to be at 0, 0, and so the vertex says 0, 0. But I like looking at it in this form. I can tell which direction it opens. This is a negative x squared graph. So do you know how it opens? Up, down, left, right? Good, down. That's a parabola that opens down. So I've got my vertex, right? 0, 0, I've got that. I'm going to go ahead and graph it next. I can find the other stuff later. I think it's important to draw the graph as soon as you can. You can kind of just look at the graph to figure out the other stuff. My pattern, which would normally be 135, is going to get multiplied by this number right here. This is your A number. And we're going to have to multiply that by 1/4. The negative just tells me it opens down. So you can put a negative in there if you want, but that's just telling you what direction it is. It multiplies by 1/4. And so if I multiply all those numbers by 1/4, 1 times 1/4 is 0.25, and 3 times 1/4 is 0.75, and 5 times 1/4 is 1.25. I already know which direction to go. I'm just going to make my pattern fit. Again, if you don't understand the pattern, then you have to just start plugging stuff in. Plug in 1, plug in 2, plug in 3, plug in whatever you want. Make an XY table, plug it in. I'm not going to do that, though. We're going to go down 0.25 and over. How did I know to go down and over? Because I already know what it looks like. It opens down. So just force that to happen. If I go down 0.75, I'm right on that number, -1. But I go over 1, and I'm right on this corner of this grid. Now, I know that looks like a V shape, but it's not. It's just a shallow, I guess, U shape. 1.25. I go down 1.25. Just got to eyeball it. And over 1. Tell you what, I'm going to go ahead and do another one. I kind of wished I had done another one on the last problem. So your pattern is 1, 3, 5, 7. If I take that times 1/4, 7/4, 1 3/4, 1.75. That's 1.75. So I can get another point if I go down 1.75. That puts me right on -4, I guess. Right there. I'd say that's good enough. That's good enough to draw a pretty good looking parabola. All right, so I've got the graph. Now, the axis of the parabola. is a vertical line right through the middle. Looks like this. It's not a number, it's an equation. It's a line. The axis of the parabola is, since it's vertical, it's going to be x equals 0. Axis. And now I need the focus and the directrix. All right, focus and the directrix. It's the hard part, I suppose. But when we start talking about the focus and the directrix, that's when we need that equation. A equals 1 over 4p. Anytime you talk about focus and directrix, you're probably going to need that equation. A equals 1 over 4p. Well, I've got the A number. The A number was this right here, negative 1/4. So negative 1/4 equals 1 over 4p. If you can just see the answer without having to do the cross multiplication, go for it. All right, but those of you that can't see what it's going to do, you can cross multiply. Negative 4p equals 4. Divide p equals negative 1. Let's talk about distance. It's distance. Now the negative just kind of tells me which direction it opens. I already know that, so I don't really need the negative part. I know the distance is 1. So all you do is go over to your picture. Go over to your picture, and we know the focus is inside the parabola at a distance of 1. And so if you know that distance of 1, then use the fact that we already know our vertex is 0, 0, and just go down 1. If we go down 1, that means that focus point is 0, negative 1. The directrix then is the line that's going to be a horizontal line like this. And it's going to be 1 above that vertex. That equation is going to be y equals positive 1. So there we've got the focus and directrix now as well. X equals would be a vertical line. Y equals is a horizontal line. Yes?
On the last one, we put the focus point above and then the directrix below. Why is that?
It depends on which direction we're open. Okay? So if I was doing this one, the focus is going to be in here somewhere, inside, and the directrix is going to be outside every single time. So it doesn't.
So it's never inside. It never goes through the parabola. It's always on the outside of it.
What is?
The directrix.
Yes. Yeah. So if I do it this way, the directrix over here and the focus is in here. The focus is always inside. The directrix is always outside. Great question. Write an equation for a parabola with focus 0, 3/4, and a vertex at the origin. So it doesn't say to draw it, but I am absolutely going to draw a picture of this. Okay? Quick little sketch. I know the vertex is at the origin, right? And they tell me the focus is at 0, 3/4. So let's just put that right here. 0, 3/4. That's the focus, right? So that must mean that your parabola looks like this, because the focus has to be inside, right? The focus has to be inside. So we can see a couple of things from this picture. We can see the vertex is 0, 0. We can see that this is pointing up, and so this has got to be a y equals x squared graph, or y minus 0 equals something times x minus 0 squared. That's what it looks like. But what's missing is this number right here, which is a. We need to know that a number. Well, we have a formula for that. A equals 1 over 4p. In this case, they didn't tell us outright, but our picture implies that that distance right there is just 3/4. But that's p. That's p. P is that distance. So I can put A equals 1 over 4 times 3/4 right here. And 4's cancel, so A is just 1/3. It looks like this number is going to be 1/3. So my equation, y equals 1/3 x squared. Example 5. Write an equation for the parabola with vertex -2, 3 and focus -2, 2. So I'm going to use the graph here to my advantage. -2, 3 is the vertex, -2, 3. And the focus is at -2, 2. So that tells me a lot of information right there. That tells me, I don't really, do I have to graph it? Yeah, I have to graph it. But that kind of tells me that it opens like this. I don't know how accurate that is, but that means that this must be a negative x squared, right? I know this equation is going to look something like this, negative x squared. Now that's not the graph, I'm not accurate enough, but it also tells me an important piece of information because of this distance right here. P equals 1. That's going to be an important part of this calculation. So I know it's y equals negative x squared, or that's kind of my starting point. But with my vertex showing, I could say y minus 3 equals something times x plus 2 squared. It's going to look like that. And that something is an a value. And I don't know what a is. I don't know what the a value is, but I do know what p is. And so I'm going to use that same formula that we used before. A equals 1 over 4p. Well, p is 1. P is 1, so a equals 1 over 4 times 1. A is 1/4. So that's going to be 1/4, except since I know that it points down like this, that must be a negative. That must be a negative 1/4. Basically just to make it point down. So let's rewrite. Y minus 3 equals negative 1/4 times x plus 2 squared. There's your equation. So if I want to graph this thing, I've already got my vertex. And if I'm going to graph my 1, 3, 5 pattern, I've got a multiplier of 1/4. So that's going to be 0.25. And 3 times 1/4 is 0.75. And 5 times 1/4 is 1.25. I can use that pattern. So start at the vertex, go down 0.25 and over 1. Then go down 0.75 and over 1. Then we go down 1.25 and over 1. And if we wanted to go even more, we could go 7 times 1/4 is 1.75. So down 1.75 and over 1. Look like that. That's probably about right. There we go. I've got the equation and the graph. Now I need the domain and the range. Domain, squish that onto the x. That looks like all real numbers. Range, squish onto the y. It looks like it's from -infinity up to +3.